Open your browser and head over to KiCad.org. Click on the Download button. Now, select your operating system. Next, choose your platform type. Then select a server to begin the download. Once that's done, open the file and follow the installation steps. It's super simple. Just follow the prompts and you'll be good to go. Once installed, launch KiCad. When you open KiCad for the first time, this is what you'll see, the main project window. Let me give you a quick tour. On the left side, you'll find options to create a new project, open an existing project, and zip or unzip project files. Over on the right, you'll see your essential tools like the Schematic Editor, PCB Editor, Symbol Editor, and more. To start a new project, click on New Project. Give it a name. And make sure you check Create a New Folder for the project. This keeps your files neat and organized. Then hit Save. You'll now see two files automatically created, one for your schematic and another for your PCB layout. Go ahead and double-click the schematic file to open the Schematic Editor. Now that we're inside the Schematic Editor, let's take a look around. At the top, you've got your main toolbar where you can find tools like Save, Zoom, and various other tools. On the left, there are tools for page setup and structure. The right side is where you'll find tools for actually building your schematic. At the bottom, there's a panel showing page info, like grid size, file location, and dimensions. Let's quickly get the page set up. Go to File in the toolbar. Next, go to Page Settings and select your preferred size. Next, select Page Orientation. Now fill in the project details, like issue date, revision, title, company name, and any extra comments. After adding all the details, click OK. And you'll see all that information appear at the bottom right of your schematic page. To enable or disable grid lines, you can click on Show Grid. To change grid size, right-click on Show Grid, go to Edit Grids, and select your spacing size from the grid column. To set the page dimensions, you have 3 measurement tools to choose from. The first option lets you work in inches. The second one switches the units to mils, that's thousandths of an inch. And the third option sets your dimensions in millimeters. Just pick the one that best fits your project. If you prefer using crosshairs across the entire window, you can enable the full window crosshairs option. If you want to display the hidden pins of a component, simply turn on the Show Hidden Pins option. If you want to add a logo, click Place Image. Select your logo and resize or move it wherever you like on the page. And one last thing, to protect your progress, let's set autosave. Go to Preferences. Next, click on Preferences. And then go to Common. And change autosave time to 3 minutes. Hit OK and you're good to go. To place components, click Place Symbol or just press A on your keyboard. Use the filter box to search for the component you want. Now select the component and click OK. To add more components to your schematic, make sure the Place Symbol tool is selected. Then, just click on an empty space in your workspace and choose the components you need. Repeat this process until you add all the components. Now I have added all the components that required except ground. To add a ground connection, click on the Place Power Symbol button or just press P on your keyboard. In the search window, type ground. Select the appropriate symbol and place it into your schematic. Before moving further, let's learn a few helpful shortcuts to speed things up. To move all components at once, click on Select Items. Then drag to select all the components. Hover over any selected component, then click and hold the left mouse button. Drag everything to the new location and release to drop them. To move a single component, hover over it and press M. Then use your mouse to move it and click the left mouse button to place it. To zoom in or out, hover your mouse over the area and scroll the mouse wheel. To pan the view, press and hold the mouse wheel button, then move the mouse around. To rotate a component, hover over it and press R. To duplicate a component, hover over it and press Ctrl+D. To edit a component's value, hover over it and press E. Then enter the new value in the value field. Using these shortcuts, go ahead and arrange the components according to your schematic. So here, I've arranged all the components as per the schematic design. Next, let's connect all the components. To do that, select Draw Wire, or just press W on your keyboard. Now choose one of the 3 line modes. This first option allows you to draw wires only vertically or horizontally. The second one lets you draw wires at any angle. And the third restricts wire angles to 45 degrees. Now start connecting the components together. While wiring, make sure all connections are properly made. If you look closely here, this wire is not properly connected. It might look attached, but isn't. And here, you can see the wires are correctly connected. So keep an eye on those details as you connect the rest of the circuit. Now, I've connected the components partially. To connect the remaining parts of the circuit efficiently, let's use global labels. First, rearrange the schematic so everything is clear and organized. Then, click on Place Global Labels. Enter a label name and keep the rest of the options as default. Click OK and place the label where you need it in the schematic. Now, connect the label to the circuit using a wire. Suppose you want to connect this node to this node in the circuit. To do that, simply duplicate the label you just created, place it near the second node, and then connect it using a wire. Repeat this process for all the remaining connections. And with that, the schematic is now complete. Next, let's annotate the components. Click on Annotate Schematic in the toolbar. In the Annotate Schematic window, click on Annotate to automatically annotate the schematic. Now let's assign footprints to the components. Click on Assign Footprints in the top toolbar. This opens the Assign Footprints window. Start by selecting the components you want to assign footprints to. From the Footprint Libraries column, choose the appropriate library. Then, from the Filtered Footprints column, select the matching footprint for the component. To preview the selected footprint, click on View Selected Footprint. If you'd like to see it in 3D, click on the 3D viewer. Once you've found the correct footprint, double-click on it to assign it. To assign a footprint to multiple components, hold down Ctrl, select all the parts you want, and then assign the footprint just as before. Repeat this process for the remaining components. After assigning all the footprints, click Apply, and then OK to save it. Awesome! Your schematic is now ready for PCB layout. Before we move on to creating the PCB layout, let's see how to export the Bill of Materials, or BOM. To do that, go to Generate Bill of Materials in the top toolbar. Next, select the desired format for your BOM, such as CSV or others. Click Export, and then click OK. Now go back to the main project window. Here, you'll find the newly generated Bill of Materials file. Just double-click it to open and review your BOM. Next, let's begin designing the PCB layout. To do that, you need to make sure you've completed all the previous steps. Once everything is done, click on Switch to PCB Editor. Now to import the layout, click on Update PCB from Schematic. In the window that opens, click on Update PCB. As you can see, we're getting 2 errors. This usually means that the PCB footprint assigned to a component does not match the number of pins or pads. In this case, the transformer footprint has only 3 pins, but we need 5 pins. So let's go back and change the footprint. Follow the same procedure for assigning the footprint that I showed earlier. Once you select the correct footprint, click Apply, and then OK. Now go back to the PCB editor and click Update PCB from Schematic again. Click Update PCB, and this time, you'll notice there are no errors. So close the window. Now place and arrange your PCB components on the layout. Use the shortcuts we learned earlier to help you move and organize the layout efficiently. Once you're done arranging the layout, click on 3D Viewer to preview your board in 3D. This gives you a clear idea of how your physical board will look. Let's now add the borders to your PCB. To do that, first, select the Edge Cuts layer. Then choose the Draw Rectangle tool. Now draw a border around your PCB layout to define its physical dimensions. To add mounting holes, click on Choose Footprint or press A on your keyboard. Search for mounting hole and place it wherever necessary. As I don't need a mounting hole, I am deleting it. Now let's look at how to add missing 3D parts. As you can see, some components might be missing their 3D models, for example, terminal blocks. Let's add them manually. Open your browser and go to Google, then search for the missing part, for example, terminal block 3D model. Click on the first link from grabcad.com. Browse through and find a suitable model for your component. So I found this design which suits my requirement. Click to open it. Now check if everything is okay. and then click on Download. You may need to create a free account to proceed. After downloading, extract the zip file. Inside, look for a folder labeled Step or containing .step files. Delete all other unnecessary files that are not step files inside that folder. Now rename the folder as you like and copy it. Next, go to your KiCad installation directory, usually on C drive or wherever you installed it. Now go to Share. Next, go to KiCad. Then go to 3D Models and paste your copied folder inside it. Now return to your PCB layout. Hover over the terminal block footprint and press E to edit it. Go to the 3D Models tab. Click Add, then click on the folder icon. Navigate to the folder where you pasted the 3D model. Select the appropriate step file and click Open. Now adjust the position using the rotation and offset tools as needed. Click OK to confirm. Repeat this process for any other missing 3D models. Once complete, open the 3D viewer again. Your board should now show the newly added parts and look much more complete. If you want to adjust the position of any footprint, do it now, because in the next section, we'll move on to routing the PCB. After making all the changes, do a final check of the board using 3D viewer. Alright, let's get started with routing. Before we begin routing, let's define a few track widths. Click on the track dropdown and choose Edit Predefined Sizes. Under the track column, click Add and enter the widths you'll need for your project. Once you've added them, click OK. Now choose a track width from the dropdown. Next, click on Route Single Track or just press X on your keyboard. Then, from the Layer dropdown, select F.cu or the front copper layer. Now start routing your track. As you route, you can monitor the unrouted connections from the indicator right here. If a clear path isn't available on one copper layer, you can switch to another layer. And then continue routing. In some cases, like here, I have one unrouted connection left, but the path is blocked on both layers. To solve this, we'll use a via to switch layers. Click on the via dropdown and select Edit Predefined Sizes. Under the via column, click Add and define your via size. Once you've added the size, click OK. Now, select the via size from the dropdown. Next, start routing from the pad where you want to begin. In this case, I'll start from here. Since this pad is close to a front copper wire, I'll switch to the bottom copper layer. When you reach the point where the path is blocked, right-click and then select Place through Via or press V on the keyboard. Now left-click to place the via and switch the layer. Then continue routing from there. Here's how the via looks in the 3D viewer. Now let's add a filled zone to connect all ground pads. Select Draw Filled Zones and click on a corner of your PCB board to start. In the pop-up, choose the ground net and click OK. Continue selecting the remaining corners to complete the zone. Now change the copper layer and then repeat the same process. Now press B on your keyboard to fill the PCB with copper. Here's how it looks in the 3D viewer. To add custom labels, let's temporarily remove the copper fill by pressing Ctrl+B. This gives us a clear view of the board. Now hide the F.fab and B.fab layers. Select either the front or back silkscreen layer depending on where you want your label. Use the shortcuts we learned earlier to neatly organize the component labels. After organizing, click on the text tool. Now type in your label and place it where you want. Now do this for all the text labels you need. Once you've finished adding labels, bring back the copper fill by pressing B again, and preview everything in the 3D viewer. To export, click on Plot. Next, click on the folder icon. Now create a new folder and select it. Now select the same options as shown here and click Plot. Then click Generate Drill Files. Now enable the Generate Map option and choose PostScript from the drop-down. Click Generate Drill File to complete this step. Now close the plot window. Go back to your main project window and select the Gerber folder. Click the plus icon to view all your generated files. To zip everything, select the Gerber folder and choose Archive All Project Files. Click Save to create the zip file. You can now upload this zip on any PCB fabrication website to get your board manufactured. And that's it. If you have any questions or get stuck anywhere, drop a comment below. I'll be happy to help. Please don't forget to like, share, and subscribe. Thanks for watching, and I'll see you in the next one.